Hey everyone, from roads that float on water to roads that glow in the dark, in today's video we're taking a look at the 15 most amazing experimental roads. Let's begin with number 15, floating roads. Roads can be built across most terrains, but there are still some, particularly where the ground moves a lot, where it does remain tricky. Floating roads, though, are a practical and innovative solution that's being implemented now. These roads are designed to stay afloat on areas of water, such as lakes, rivers, or coastal regions, making transportation possible in places where construction of traditional ones are unfeasible. The technology behind it involves these modular sections, or pontoons, made from lightweight, buoyant materials such as reinforced plastic, fiberglass, or concrete. Their modular nature allows for flexibility and adaptation with changing water levels and condition, and in addition they can be assembled relatively quickly, providing a rapid response to urgent transportation needs. Floating roads are particularly useful for regions that are prone to flooding or where water levels fluctuate. Floating roads can rise and fall with the water level, providing a durable and resilient option. These roads also have the potential to lessen environmental impact, as by adapting to the surface of the water they reduce the need for extensive land alteration. They can be designed to allow for water flow and movement of aquatic life beneath them, minimizing disruption to any ecosystems. They do, though, have their own issues, such as ensuring stability in changing weather conditions, maintaining buoyancy, and ensuring the safety of travelers. For now, they're only viable in certain scenarios, but as the climate continues to change, may become more commonplace all over the world. Number 14. Bioluminescent trees instead of lights. There are believed to be around 304 million active street lamps on roads around the world, and while they are vital for safety, this represents a huge use of energy. Researchers continually look at ways to make them more efficient, such as by using better bulbs or by only switching them on when there are cars on the road. But there's a new, radical idea that could see the end of all street lamps as we know them. The idea of using bioluminescent trees seems like it's straight out of a science fiction novel, but it isn't as ridiculous as it may initially seem. Bioluminescence, which is the process by which living organisms emit light, is a natural phenomenon present in some species of algae, jellyfish, fireflies, and fungi. And through genetic engineering, these genes responsible for bioluminescence can be inserted into trees, potentially creating natural light-giving sources along roadways. The use of these trees as roadside lighting is an appealing concept that promises to reduce energy consumption and CO2 emissions associated with traditional electric lighting. It fits with the broader movement towards sustainable and environmentally friendly urban planning and would not only provide illumination but also contribute to the aesthetic and psychological well-being of residents, creating a calming and more natural nighttime environment. Research into the practical application of these trees is still in its early stages, though, with the main challenge being the amount of light produced by them, which is currently not enough to illuminate roads. There are ethical and ecological considerations concerning the release of genetically modified organisms into the environment, with the impact on local ecosystems and crossbreeding with native species being an unforeseen and potentially damaging risk. Number 13. Whispering asphalt. So, roads produce various types of pollution, but particularly for those that live in urban areas or near a highway, the biggest disruption comes from the sound of cars passing by. Part of this is caused by the road's surface itself, but with the advent of more advanced materials, this could be a thing of the past. One solution is whispering asphalt, or quiet pavement, which uses special materials and designs that absorb sound waves from vehicle tires. It's actually made up of a fine and open porous structure that traps and dissipates the sound waves, with the upper layer of the pavement where the tire meets the road being engineered with gaps to allow for airflow and sound waves to enter. This design also adds the added benefit of improving water drainage, thereby reducing splash and spray in wet conditions. The installation of these roads can lead to significant decreases in traffic noise, sometimes cutting the perceived noise level in half and reducing the need for other solutions such as sound barriers. Although already in use in some places, there are issues with this type of road service, which means further developments are needed before it's more commonly seen. Apart from increased cost, there are questions over the durability, lifespan, and maintenance requirements, and the open pore structure can become clogged with debris over time, which may necessitate more frequent cleaning to maintain its noise-reducing properties and prevent surface water accumulation. Number 12. Kinetic energy harvesting roads. Kinetic energy harvesting roads are ones that have been designed to capture the kinetic energy generated by the motion of vehicles and convert it into electrical energy. Now, this form of energy harvesting is a potential game changer in terms of producing clean power and would significantly reduce emissions across the transport network. These are roads that are equipped with a variety of mechanisms, such as piezoelectric materials or electromagnetic systems embedded within the surface. As vehicles pass over these materials, the pressure and vibrations caused by the weight and movement of vehicles induce an electric charge or generate a magnetic field, which can then be harnessed and transformed into electric current. This could be used to then power the street lights, traffic signals, and roadside charging stations for electric vehicles. The obvious benefit of this type of technology is its ability to produce energy from existing traffic flow without the need for additional input or resources. Unlike solar or wind power, which depend on weather conditions and require extensive land or space, kinetic energy harvesting can be integrated into existing road structures. As exciting as all this may be, we're still far from a future where this is everywhere. Functioning versions have already been installed in several places, but the initial investment costs for such technology are a bit prohibitive right now, and will have to fall dramatically before this concept is viable on a large scale. Number 11. Plastic roads. So, most roads around the world are made in a similar way, with durable materials designed to accommodate many years' worth of traffic. Our understanding of materials, though, now means that alternatives are being looked at, with one of the more promising being plastic. This idea involves using recycled plastic waste to build or repair roads, effectively addressing environmental concerns while creating more resilient road surfaces. The construction of these plastic roads involves melting down plastic waste, which is then mixed with asphalt. This mixture can include a variety of plastic materials such as polyethylene, polypropylene, and polystyrene, which are often sourced from consumer waste like bottles, bags, and packaging. One of the biggest benefits of these plastic roads is their potential to reduce the carbon footprint associated with road construction, as the use of recycled material saves on the quarrying. Moreover, plastic roads are quicker to lay, reducing construction time and the associated emissions from the machinery. And they can help to alleviate the pressure on waste disposal systems and mitigate the impact of plastic pollution. Roads like these have been tried in several different countries, with some regions incorporating modular plastic paving tiles or entire sections made from recycled plastics. These trials have demonstrated not only the viability of plastic roads, but also their potential advantages over asphalt in terms of durability and maintenance. But like with every road surface, particles are worn away every time a car passes over, and this risks releasing large volumes of microplastics into the environment. It's not yet clear how much of a risk this poses or what the expected lifespan of a plastic road will be, so far more research is needed before plastic is considered as a widely used material. Number 10. Heated roads. Different regions experience vastly different weather conditions, with ice and snow being particularly treacherous if you want to drive. You've probably seen some people having heated driveways to help defrost their properties, but now there's a big push in some colder regions to look at heating entire roads. The concept is simple. By integrating heating elements within or beneath the road's surface, snow and ice can be melted on contact, thereby preventing accumulation and the associated hazards. This technology typically uses electrical elements or hydronic systems that circulate heated fluid, often glycol or water, through pipes embedded in the road. Some systems can even utilize renewable energy sources such as geothermal heat or solar panels to warm the fluid, minimizing the environmental impact. When done properly, this does improve road safety during winter by reducing the risk of accidents caused by slippery conditions. For local governments, heated roads can mean a reduction in the need for snowplows and salt, leading to cost savings in the long run and some less environmental damage from salt runoff. Furthermore, heated roads have the potential to extend the lifespan of road infrastructure, as the freeze-thaw cycle is one of the leading causes of road deterioration, when water seeps into cracks, freezes, and expands. By maintaining the pavement temperature, heated roads could prevent that cycle, reducing maintenance costs even further. There is, of course, a huge upfront investment that's needed, and this is the main reason they aren't already more common, as the technology already allows for roads to be heated in this way. Most authorities are more likely to choose to spend funds on larger projects like bridge construction instead. With heated roads, they're seen as a very low priority. The efficiency of heated roads also varies based on the installation quality, local climate conditions, and the technology used. And if the electricity used is not from renewable sources, the environmental benefits could be negated by the increased carbon footprint. Number 9. Fog warning and dispersion system. One of the biggest dangers that road users face is changing weather conditions, particularly when it affects your visibility, and there's perhaps none as potentially treacherous as fog. Fog warning systems involve a network of sensors and communication devices that monitor weather conditions in real time. These sensors detect reduced visibility and activate warning signals, and variable message signs along the roadway then display alerts, advising drivers to reduce speed and exercise caution. In addition to these warning systems, there are advanced technologies that actually aim to actively disperse fog to improve visibility. One such method is the installation of fog dispersion devices that work by injecting heat into the air to increase the temperature and reduce the relative humidity, causing the fog to dissipate. All of these can prove to be extremely expensive though, and they're really not feasible in places where fog is a rare occurrence. They are being tried out, however, in some regions where it's far more common, and mobile devices are also being trialed that could be deployed to areas of risk as weather systems begin to develop. Number 8. Solar roads. If you've ever felt how warm the asphalt off a road can get in warm weather, you'll know just how exposed roads can be to the sun. So it seems like a logical step to try to use this to generate energy. Solar roads then involve embedding solar panels within the surface, parking lots, driveways, sidewalks, in order to transform the area into generators of clean electricity. Now, the idea of solar roads gained some significant attention with projects like the Solar Roadways in the United States and Solar Road in the Netherlands, showcasing a potential for integrating photovoltaic cells into the road surface. These solar panels are designed to be tough enough to withstand the weight and wear of passing vehicles while being transparent enough to allow sunlight to reach the solar cells. The benefits are clear to see, but it's not proven to be so simple to implement. The energy generation efficiency of solar panel on roads is generally a lot lower than that of a traditional rooftop solar installation. And the durability and long-term performance of these panels under constant traffic, along with the high initial costs of installation and maintenance, are also problems that need to be overcome. Ongoing research and pilot projects continue to explore the viability, though. While solar roads may not be yet a widespread feasible solution, they do show a forward-thinking approach to integrating renewable energy into our everyday infrastructure. Moving on to number 7, wireless charging roads. One of the biggest challenges facing the widespread use of electric vehicles is the ability to recharge the batteries. But rather than having to stop while charging, what if you could continually top up your charge while driving? The technology behind wireless charging roads involves installing coils under the surface of the road that generate an electromagnetic field. When an electric vehicle equipped with a compatible receiver drives over these sections, the electromagnetic field is converted into electrical energy, charging the vehicle's battery. This process, known as dynamic wireless power transfer, allows for continuous charging during travel, potentially enabling EVs to cover longer distances. Several countries, including South Korea, Sweden, and Israel, have begun pilot projects to test the feasibility and efficiency of these wireless charging roads. These ventures aim not only to refine the technology, but also test its practicality and durability. The installation and maintenance of such infrastructure, though, requires significant investment, and the efficiency of energy transfer depends on the speed of the vehicle and the alignment of the coils. So standardization across different manufacturers and vehicles remains a critical issue to ensure compatibility and widespread adoption. As the research and development continue, wireless charging roads seem like an almost inevitable future, and when it does, we'll speed up to the transition using electric vehicles and ultimately reduce greenhouse gas emissions and contribute to a more sustainable future. Number 6. Pedestrian scramble crossings. Infrastructure designers are continually looking at alternative ways that we can use what we already have in a more efficient way, and pedestrian scramble crossings are a great example of this. The most famous in the world is the one in Shibuya in Tokyo, but the concept actually originated in Canada. During a pedestrian scramble phase, all traffic lights for vehicles turn red, and pedestrians can cross the intersection in every direction at once. This system eliminates the conflict between turning vehicles and crossing pedestrians, significantly reducing the potential for accidents. Pedestrian scrambles have several key advantages. They improve the efficiency of pedestrian traffic, especially where large crowds tend to gather, and by allowing pedestrians to cross directly to their destination without having to wait for multiple signals, overall crossing time is reduced. They can also make intersections more orderly by simplifying the signal timing and traffic movement. Without the need to synchronize pedestrian crossings with vehicular turns, traffic flow can become more predictable and potentially smoother. Having now been trialed at a number of high-traffic locations in major cities around the world, they're seen as a smart solution, and many more are currently being planned. It's not as simple as just painting a crossing like this one on the road, though. They do require careful planning and consideration. They're most successful in areas where pedestrian volumes are high and vehicle-pedestrian conflicts are a significant concern, but it can increase the wait time for vehicles, potentially leading to more congestion. Additionally, if not used properly or designed, scrambles can confuse both pedestrians and drivers unused to the system. So education and clear signage are essential to ensure that all road users understand how the crossings operate. Number 5. Self-repairing roads. So one of the biggest annoyances and costs associated with roads around the world are because of the deterioration of the surface, which not only causes discomfort but can damage cars too. Potholes are a common sight wherever you go and often require costly maintenance to manage. But by using different materials to build the road in the first place, we could avoid the problem altogether. So-called self-repairing roads involve the use of self-healing asphalt or concrete. These materials contain capsules or vessels filled with a healing agent, such as bitumen or a special glue-like substance. And when the road surface cracks, these capsules break open and the healing agent is released into the crack. Under the sun's heat, through the catalyst embedded within the material, the agent reacts and solidifies, effectively sealing the crack. Another method incorporates the use of bacteria within concrete. When cracks form, the bacteria, which lie dormant until exposed to water, begin to metabolize, producing limestone as a byproduct. This limestone then fills in the cracks and solidifies, restoring the integrity of the concrete. There's also the option of using smart materials like shape memory alloys that can return to their original shape after deformation, which could be embedded in critical stress points of a road. But having said all that, there is an increased upfront cost, and while some self-healing roads have already been built, researchers are studying them closely to fully understand how effective they are in the real world. Number 4. Barrier transfers. Once a traditional road is built, users are limited to the lane setup, even if there's far more traffic moving in one direction than the other. This can result in traffic jams on one side and open roads on the other, but some organizations have been developing tools that allow the roads to be fully customizable depending on the use. Barrier transfer machines, also known as zipper machines or movable barrier machines, are a dynamic traffic management solution that allows for the reallocation of road space. These machines adjust concrete or steel barriers between the traffic lanes, usually to manage commuter traffic flows that have a predictable pattern. The concept is really useful during rush hour periods when the volume of traffic heading into or out of a city is significantly unbalanced. In the morning, there's often a greater need for more lanes heading into the city, while in the evening the reverse is true. A barrier transfer machine can move the median barrier to temporarily create additional lanes. These machines work by lifting the barriers, which are linked together by steel connectors that create a continuous but flexible sort of chain, and then shift them laterally to a new position on the road. The efficiency and speed of a barrier machine like this allows for daily changes in road configurations, with some systems able to move several miles of barriers in under an hour. While it's not perhaps the newest of all road technologies, with versions of these having been used for a few decades now, more and more cities are needing to relook at how the roads are being used and how they're looking to incorporate new technologies to the concept to have a truly adjustable road network. Number 3. Virtual traffic lights. So traffic lights are a critical tool in organizing the movement of traffic, but they're only able to give signals in the fixed positions where they've been installed. As our cars become more advanced, there's a way to use technology to send signals more often, and this could significantly improve journey times and road capacity. The idea of virtual traffic lights is a cutting-edge concept that moves away from traditional physical traffic light systems and instead uses a vehicle-to-vehicle and vehicle-to-infrastructure communication technology to manage traffic flow. Using this data, a virtual traffic light system dynamically assigns the right-of-way to vehicles, displaying traffic signals directly to drivers through in-vehicle displays or smartphones. This means that the traditional fixed cycle of red, yellow, green is replaced by a flexible, real-time system. One of the main benefits of these virtual traffic lights is their potential to significantly reduce congestion. By optimizing flow based on actual conditions, they will eliminate the need for vehicles to stop at empty intersections. Furthermore, virtual traffic lights can react instantaneously to changes in traffic patterns, such as those caused by accidents or road closures. Virtual traffic lights also promise enhanced safety by coordinating vehicle movements at intersections, which will reduce the risk of collisions. Additionally, these systems can prioritize emergency vehicles, ensuring they can navigate through traffic with minimal delay. Number 2. Urban wildlife tunnels. Urban wildlife tunnels are specially designed passageways that allow animals to safely cross human-made barriers such as roads, highways, and urban developments. These structures are in response to the growing recognition of the need to preserve biodiversity and maintain ecological balance within expanding urban environments. And by providing safe crossing paths, urban wildlife tunnels help mitigate the negative impacts of habitat fragmentation. They aren't a new concept. Versions have been around for several decades, but with new technologies and a huge amount of infrastructure development taking place around the world, designers are now able to plan the wildlife tunnels from the outset instead of adding them to existing routes. Depending on the needs of the species in the region, the tunnels vary in size, shape, and material. For smaller creatures like amphibians, reptiles, and small mammals, tunnels might be small and humid, often with vegetation lining the sides to provide a naturalistic passage. While for larger mammals such as deer, elk, or even predators like bears and mountain lions, tunnels are significantly larger, sometimes incorporating natural light and vegetation to encourage their use. Strategically placed along migration routes or in areas of high animal traffic, they are often part of a larger wildlife corridor project. The success of these tunnels is then encouraged by fencing that funnels animals towards the crossing, preventing them from attempting to directly cross the dangerous road. When done properly, they play a critical role in preserving genetic diversity by allowing animals to mix in with populations on the other side of barriers. By reducing wildlife vehicle collisions, they also contribute to public safety and can result in significant economic savings in terms of reduced accident costs. Number 1. Autonomous vehicle lanes. Road users have become used to seeing lanes that are reserved for certain vehicles, such as buses or even cars with a certain number of people in them. But with a revolutionary new technology expected to be on the roads in a matter of years, there are now plans to add a new type of lane, one that's dedicated to users of autonomous vehicles. The idea is that these lanes will enhance traffic flow, increase safety, and maximize the efficiency of autonomous transports. As by providing a segregated pathway, AV lanes can avoid the complexities associated with mixed traffic environments where human-driven and autonomous vehicles interact. The push behind dedicated AV lines comes from the unique capabilities of autonomous vehicles to communicate with each other and with traffic management systems. This connectivity allows AVs to maintain optimal speeds, execute precise maneuvers, and adjust traffic conditions in real time. In dedicated lanes, these vehicles can operate in tightly coordinated platoons, maintaining closer distances than would be safe for human drivers. Dedicated AV lanes can also serve as a testing ground for advancing autonomous technology in real-world conditions, providing valuable data to refine algorithms and improve vehicle performance. This can accelerate the overall adoption of AV technology by reducing idling and harmonizing speeds, which can lower emissions, contributing to cleaner urban air. The implementation of dedicated AV lanes also reflects a shift toward multimodal urban ecosystems. These lanes can be integrated with existing transportation networks, offering a seamless transition between different modes of transport. For instance, AVs could be used for the last-mile connection to public transit hubs, enhancing the accessibility and convenience. With some cities already having installed lanes like these on some roads, so companies that are developing autonomous vehicles can prove the concept works, it's likely going to be one of the ways that the transition between the human-driven cars and autonomous ones is handled. That way, autonomous vehicle drivers can reap the full benefits of using that mode of travel, while drivers of traditional cars won't have to contend with driving alongside cars without drivers, and the reduced visual communication that comes as a result. Thanks for watching, everyone. I will see you next time. Thank you to our channel members.